Here we have AP calculus AB problem. Okay, let's go to the question. If f is a continuous function and if f prime of capital F prime of x equals to lowercase f of x for all real numbers x, then integral 1 to 4 f of square root of x divided by square root of x dx equals to. Okay, using the given information, we have to get the value of this definite integral. Okay, now let me consider this particular stuff. We have over here that is capital F prime of x equals to f of x, that is lowercase f of x. Okay, now in this equation, if I want to solve for f of capital F of x, that is how I want to get up this derivative over here. Okay, now to get up this derivative, what I have to do is I have to take antiderivative, that is integration on both sides. That is integration of capital F prime of x dx equals to integration of f of x dx. Okay, here actually integral is the antiderivative. This antiderivative and this derivative will cancel out and dx also will be removed. We just get capital F of x on the left side. On the right side we have integration of lowercase f of x dx. Okay, now we can keep this result in record because I'm going to use this one later in evaluating this definite integral. Okay, so here if I want to use this result in this definite integral, so in the integral must be just f of x or f of y or whatever it is. We just have f over here, f of x or f of y or whatever it is. So then we can use a result over here. But when I look at the integrand over here, we don't have f of x or f of u, something like that. So if we have a square root of x inside the parenthesis, and in denominator also we have square root of x. Okay, so what I'm going to do is I'm going to use the method of substitution to get the square root of x in denominator and also just get single variable over here instead of square root of x. Because when I look at the stuff over here, we just have single variable inside the parenthesis. Okay, how can I decide that we have to use method of substitution to get single variable over here and also to get rid of square root of x in denominator? Because if I want to use method of substitution in an integral, so the derivative of a part of the integrand will be in the integrand itself. When I consider the square root of x over here, its derivative is 1 over 2 times square root of x. That is the derivative of square root of x is 1 over 2 times square root of x. So its derivative is almost over here. That is 1 over square root of x. We may ask a question, 2 is not there. So it's not a problem. The constant multiplied over here is not does not exist over here. That we can adjust it. Okay, anyways, so let me assign a new variable u for this square root of x because we have the derivative of this square root of x over here. So that's why I'm going to assign a new variable for this square root of x. And also my aim is to get single variable inside the parenthesis over here so that we'll be getting this structure f of just x. Okay, now let me assign a new variable for this one. Let u equals to square root of x. Okay, since I have assigned a new variable u, I have to get this complete integration in terms of the new variable u. So when I get the complete integration in terms of the new variable u, at the place of dx, I must have du. If I want to get du, what should I do with this u? I have to find derivative. And also u is a function of x. Since u is a function of x, we can find derivative on both sides with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. And just now we know that the derivative of square root of x is 1 over 2 times square root of x. Okay, now I have to solve for du in this case. For that we have to get rid of this dx. And also one more thing we can note is we don't have 2 times square root of x in denominator, we just have square root of x. So here we have to get rid of this 2 also. Okay, now let me multiply both sides by 2 times dx. Okay, 2 times dx. Okay, so here I multiply both sides by 2 times dx because my aim is to get up this dx in denominator over here and the 2 in denominator over here. Okay, now this dx and dx will cancel out. This 2 will cancel out. We get 2 times du on the left side. On the right side we have 1 over square root of x times dx. Now let me rearrange the terms in this definite integral over here. That is f of square root of x, and the denominator square root of x can be written as 1 over square root of x and times dx over here. Actually this 1 and 4 are the limits of the variable x. Okay, now I'm going to change this complete integration in the new variable u. So in that case I have to change the limits also to the new variable u. So here the lower limit of x is 1. When x equals to 1, what is the lower limit for u? To get the lower limit for u, we have to plug in x equals to 1 over here in this equation. Then I'm getting u equals to square root of 1. Square root of 1 is just 1. Now let's consider the upper limit of the variable x, that is x equals to 4. When x equals to 4, then we get u equals to square root of 4. I plugged in 4 for x over here. Square root of 4 is just 2. Okay, when x equals to 1, for u also we get the same limit 1, and for x equals to 4, we get u equals to 2. Okay, now let me write. Okay, here in this integration we can write the same limits 1, 4 because still the integration is in the variable x. Now I'm going to change this complete integration in the new variable, that is f of for the square root of x we can plug in u, f of u, and for this 1 over square root of x times dx we can plug in 2 times du. Now we got the complete integration in terms of the new variable u. Now we have to take the limits of the variable u, that is 1 is the lower limit and 2 is the upper limit, 1 to 2. Okay, here in the integrand f of u is multiplied by constant 2. Whenever there is a constant multiplied in the integrand, it can be taken out of the integral. Then we get 2 times integral 1 to 2 f of u du. Here we got a result, that is integral lowercase f of x dx equals to capital F of x. When I consider the integration over here, whatever stuff we have over here, the same stuff we have. Instead of x, we have u over here. So for this integration, the result is capital F of x. Then for this integration, we have capital F of u. And also it's a definite integral, that is we have the limits 1 and 2. So the same limits we have to apply for the result of the integration, that is 1 to 2. And we know that these are the limits of u. Now what we have to do is we have to plug in the upper limit 2 for u over here in the result. Then I'm getting 2 times f of 2. Before I apply the lower limit 1 for u, I have to take a negative sign. Now in this result, let's plug in the lower limit 1 for u over here. Then I'm getting f of 1. Okay, now I got the result of the given definite integral, that is equal to 2 times capital F of 2 negative capital F of 1. We find this result exactly in answer choice A. The correct answer choice for this question is A.